All right, so if you look at this question here, we have a rod, A to B, and we are told that it's uniform and it has a mass of 20 kilograms. Now, when something is uniform, we know that the weight is evenly distributed, which means the center of mass for this rod is going to be exactly in the middle. So we can draw a force here for the weight of this rod, and it's going to be 20 with a G, because weight is force, which is mass times gravity. Okay. So we also have a person right there. Okay, so we have a person right there and their weight is 70 kilograms, so they're going to be 70 G. And we have another person here, okay, on this platform, but we don't know their weight. We just will call them an M for mass times gravity, and that will represent whatever their weight is. So far, so good? Right, what else do we know? We have a pivot point right here. We know that we have a pivot point right here, and this will have a reaction force, because if anything is resting on a surface, so this rod is resting on this surface, this pivot, it will create an equal and opposite reaction force going up. So this, let's call it a reaction force R. What else do we know? We know that the distance between this point and that point is 10. So from here to here is 10 meters, right? And we also know that the distance between this point and that point is 8. So from there to there, we have 8. What we now need to do is we are going to do two things. We are going to calculate, we are going to find the mass of this, the M value, and we are going to find the reaction force R. Okay, so we're going to find M and the reaction force R. So that's what we are going to do with this question. Now, before you start these questions, it's very, very important that you label and draw your diagram correctly. So any sides that you don't know, any lengths that you don't know, it's important that you find them. So from here to here, we know that it's 10. From here to here is 8. What we don't know is that and that individually, or that even individually. All right? Now, what's the total length of this rod? 18. We know that. We can just do 8 plus 10, and we know that it's 18. That means if this is in the middle, the center of mass, from here to here, what will it be? If it's 18 in total, from here to here, which is the center, exact center, the center of mass, what will it be here? 9. So this will be 9 meters. Well, if this is 10, what's this going to be? 1 meter. And we know that this is already 8. So now we have accounted for every single length in the gaps. And we are ready to begin to answer this question. Now, often, you'd work on these together with the calculation. First calculation that you will be doing is you will be resolving vertically. Okay? So let's start by resolving vertically. I'm going to say that this is the positive direction, and it's okay. I can choose this as a positive direction or that as a positive direction. Okay? So what forces do I have which are vertical? Now this is positive, so we are going to have R as a positive. And remember, it's in equilibrium, it's balanced. So it's going to be equal to anything going down. So therefore, there's nothing else going up, so we can now put our equal sign in. And what do we have going down? We have 70 G, we have 20 G, and we have our mg. And now we can just tidy up here. So what do we get? 70G plus 20G equals 90G plus mg. Now for now, this is all we have. We can't calculate this any further because we don't know the value of m. But we can go and find the value of m by doing another calculation that will help us. And that is to resolve by the anti-clockwise and the clockwise, which means to do the moments, okay, the turning points. Now you can take moments from anywhere. So we will take from here because this is a good spot, because you can understand what the turning point is, because the rod will be pivoting on that point. So we will be taking moments from this point. So moments from, let's give this a name, let's call it, what do they call it? They don't call it anything. So moments from this point, what do we call it? C? Right, so let's give this point a name, let's call it C. So moments from C, okay? Now, when we take moments, we can actually take moments from any of these points, by the way, which you'll see later on in the questions. But when we take moments from a point where there's a reaction force, there is no longer a need to use that reaction force itself, because it's not providing any reaction anymore because it's moving along there. Okay? It's not providing stability. Right? So what we can write here is that R would be equal to 0. The reaction force there is 0. So always remember that if you're using these pivot points and it has a reaction force, which it will, then that reaction force at that point will be just 0. Okay? So we are taking moments from there. So what do we have? Let's go for our clockwise, and we are going to make it equal to our anti-clockwise. So the first thing we need to decide is which of these forces, well, this is not going to be involved, which of these forces are clockwise and which of these forces are anti-clockwise. So if you look at that, let's start with this 20 here. Now this 20 is going down and it's going to be going around this point here. Okay, it's going to be going around here, yeah? So therefore, this is going to be going what? Clockwise or anti-clockwise? Anti-clockwise. What about this one, mg? Mg is going down this way. This is our pivot point. So it's going to be going around that, right? Which is clockwise. So that's a clockwise, that's an anti-clockwise. What about this 70? It's going to be going that way, so anti-clockwise. So we have 2 anti-clockwise equal to 1 clockwise, right? So this side, let's put our clockwise on here. So it's going to be mg. Remember, to find the turning moment, the moment is force times the perpendicular distance. So it's going to be mg times by 8, all the way until that point. Okay, so mg times by 8. And we don't have any more clockwise, so we can just go equal. And then these two are going to be anti-clockwise. So it's going to be 20g times by 1. And I'm just going to put it into brackets to show that it's one calculation there. And it's going to be 70g times by, well, all the way, which is 10. Very good. And now I just need to calculate. Now, you will notice that everything has a g, so I can divide by g. So I can cancel all the g's out like that, leaving me with just 8m equal to 20 plus 700. And then I can add these together and then divide by 8. So it will be m is equal to 720 divided by 8, and I can find my m. So m is equal to 90 kilograms. Now that I have m, I have calculated m here, I just need to find my r. What am I going to do? I'm going to substitute that value of m right there. So r will be 90g plus 90 for m, and the g that's already there. So that gives us 180g. Or if you calculate 180 times by 9.8, please. So 1,764 newtons, and that is the value of r. Very, very basic question. The next 2 questions that we are going to do are going to be a lot more complicated than this. They're going to use more than one pivot point. They're going to be using more unknown lengths, etc. Okay? All right. So let's have a look at this next question. We have a uniform rod, and we are told that the mass is 40 kilograms. Now, straight away, that information will go to the center of that rod, because the center of mass, because it's uniform, will be right there, and we will write here 40g. We are also told that the length of this rod is 5 meters, which means that from here to there is 2.5, and from there to there is also 2.5. Okay? So basic information like that we'll put down straight away. We are told in the question that we have 2 supports at C and D, and both of those supports are 1 meter and 1 meter. Okay? Now, both of those supports are also going to give a reaction force. So this reaction force we're going to call reaction force at C, and this reaction force we are going to call the reaction force at D. We are also told that there's a man of mass 80 kilograms somewhere between these 2 supports. Okay? Now, if you don't know where the man should be, you can just roughly place him somewhere. Okay? Because obviously he's got to be between those 2, because if he's here, he's going to make the whole thing tilt. Okay? And same on this side. So it has to be between those 2. All right, so I'm just going to put the man somewhere here, and I don't need to draw a picture of the man. I'll just draw that, and I'll put the man's weight, which is 80 g. All right. Now, the question says to find the distance A to E. There's A, and the man is considered to be the point E. So I need to find the distance from there to there. What I will do is I will draw an arrow straight there, and I will call it X. That's the distance I want to find, the distance X. Now, everything else I need to fill in, all the missing lengths. We know that this is 2.5. We know that this is 1. So what's left over to give us 2.5? 1.5 meters. Now this one, we've got to be a bit more careful. We know that this is 2.5. We know that this is 1. This has to be distributed accordingly. All right. Now we don't know exactly how much the man is away from these points. Okay. But we'll use this X as an indicator. You see, all from here to here is X. From here to here is 2.5. What will this be? It will be X minus the 2.5. So we can write in here X minus 2.5. I don't know how well you can see that, but I'll just draw an arrow here showing this. So X minus 2.5. That will be the length right there. Okay? Let me just get rid of that totally, so it's not in the way. Yeah? So that's the length right there. What would this be then? Well, we know that this is 2.5, all of that. We know that this is X minus 2.5. So therefore, to find this, I'm just going to do it here. So to find this length here, okay, let's do an arrow coming out. It's going to be 2.5. We start with 2.5. We take away the 1, this one, and we take away that. So if we take that away, what is that? X minus 2.5. What does that give us? 2.5 minus the 1 is 1.5. And then, oh, hold on. Sorry. Oof, let's do that again. I forgot my bracket. All right. So to work out what this length is, it's going to be 2.5 minus the 1. Take away that part. And that part is X minus 2.5. So X minus 2.5. So let's work this out. What does that give me? So 2.5 minus 1 is 1.5. So I have minus X coming out of that. And then these two negatives will give me a positive 2.5. So in total, I have 1.5 plus 2.5, which is 4 minus the X. So this here is 4 minus X. It's very, very important that you get these diagrams right. If you start off using the same, using the wrong diagrams, then even if you know how to resolve forces clockwise, anti-clockwise, you will not be getting the right answers because you're going to be using the wrong values. All right. So it's really, really important that you get these calculations and you spend a bit of time on these questions, just making sure your diagram is correct and you understand how to do this. All right. So practice this on questions when you do it. All right. All right. Do we have everything we need? We have all the gaps filled in. We are now ready to resolve vertically and clockwise and anti-clockwise in equilibrium. All right, so let's begin. First of all, let's deal with the R. Now there's some information in the question. It says that the reaction force at D is twice the reaction force here, right? That means if we call this R, what would this be equal to? 2R. We can say that's worth 2R. So when we resolve, again, let's choose this way as positive. We can say we've got 2R's up, so therefore R plus 2R is equal to all the forces going down, which is 40G plus 80G. So now we tidy up. So we have 3R is equal to 120G, and therefore R would be equal to 120 divided by 3, which is 40g. Again, you could calculate the g's, so you can put that into calculations for 40 times 9.8. So if you could give me that please quickly. 392 newtons. Newtons up here as well. All right, so if you go back up here, this is equal to either 40g or 392 newtons. And therefore this one would be equal to 2 lots of 40g, so therefore 80g, or was 392 times 2, or 784 newtons. All right, and we'll use those figures in our calculations now. So what's next? We are going to resolve by taking moments, right? Now, I said to you earlier, we can take moments from anywhere. In the last example, we chose to take moments from a pivotal point. But I'm going to show you that you can take moments from anywhere you like. You can take moments from here, 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 or there. Let's take moments from A. All right, just to show you something different. So moments from A. Now, there's no reaction force at A, is there? There's nothing happening at A, so there's nothing to say something is zero, reaction is zero. However, if we took moments from the C, then this reaction force here wouldn't be in our calculation, it would be equal to zero. It wouldn't be part of our anti-clockwise and clockwise. If we took moments from here, this calculation wouldn't be part of our clockwise and anti-clockwise. But seeing that it's here, I'm taking moments from, that will all be involved in our clockwise and anti-clockwise calculations. All right? So first of all, we need to determine our clockwise, and our anti-clockwise, yeah? So taking it from here, this is going to be anti-clockwise. This is also going to be anti-clockwise. These two are going to be clockwise. So it's going to be these two on one side equals to those two on the other side. All right? So let's put that in first. So R, which is we know is, shall we use 40g for now, yeah? Let's just use 40g. So 40g times by the distance to the point that we are taking moments from, which is 1. So 40g times by 1, right? Plus 2r, which is 80g times by the distance to that point. So 80g times by the distance to that point. Now, to calculate the distance to that point, we need to add up all of this, or an easier way is, we know that this is 1, the whole thing is 5, so therefore the distance to that is going to be 4. So therefore 80g times by 4. That's a quicker way of doing it, rather than adding this, adding this, adding this, and adding that. All right, which you can also do and you'll still get to the same answer, 4. All right, now that would be equal to the other sides. So this way. So 40g times by all the way up to there, which is going to be 2.5. All right, so we've got one of those. We now need to do the 80g. So let's do the 80g. So plus 80g, oops, not 80h, 80g times by. Now, what's the distance from there to there? Now, the hard way is to add that, and add that. But if you notice, we've got the x right there. We've called it the distance x. So we can just times that by x. Yeah? Now, we've done that. We've not left anything out, so that always check if you've left anything out, okay, any forces that you haven't included, but we have. Now, can you notice all the g's, right? This is the benefit of not using this value, okay, that you still got g's and you can just cancel all the g's out. So let's do that now. All the g's can be divided, so we're dividing throughout by g, all right? So what do we have here? 40 times 1 is 40. Plus 80 times 4 is 320 is equal to 40 times 2.5, 100 plus 80x. So this is all of this simplified. Now we just collect all the like terms, all right? So you do 40 plus 320 and then take the 100 over, 260 is equal to 80x, and then you're going to divide by 80 on this side. So we're going to have x is equal to 260 divided by 80. X, please. So x is 3.25 meters. Right. So we have found the value of x, And x also happens to be the distance a to e. So that's why strategically we labeled it like that, so we can just find x once and it is our answer. So a to e is also 3.25 meters. So this last question is actually a typical exam question that you would be asked typically on a paper. Look at the amount of marks that you have. Yeah, this is like 1.5 grades. That could be the difference. That could be the change for you and your exam grade. Get one of these questions correct, all right? So we have a uniform rod, length 2 meters and mass 50 kilograms. The rod is in equilibrium, horizontal position. It's resting on 2 smooth supports at C and D, where A to C is equal to 0.2 meters and D to B is x meters. Given that the magnitude of the reaction on the rod at D is twice the magnitude of the reaction on the rod at C, find the value of x. And there's a second part to this which we'll look at once we've solved the first part. So step number 1, we're going to draw this diagram, all right? So there's our rod, here's A, here's B. We're going to put in where the supports are that they put there. So that's C. So reaction at C. And then we've got D. So reaction at D. We are told that it is uniform and a length of 2 meters and mass 50. So here will be the mass, 50g, will be the weight, the force. And 1 meter there, is it 1 meter in total? 2 meter, 1 meter there, and 1 meter, oops, not 1, and there, okay? So this is the diagram that we have so far. We are also told that the reaction here is what we're told about the reaction. So it says the reaction at D is 2 times the reaction at C. So if we call this R again, and we can call this 2R. And we've got the distances. We've got 0.2 meters here, and we are told that this is x. And we have to find what x is, the distance x, all right? So let's begin. Let's resolve this way first. We've got R and 2R, which is a total of 3R, equal to what's going down, which is just 50g. And that can just be obtained easily by doing 50g divided by 3. So we'll just leave it like this for now, and that's in newtons. All right? We can calculate this as a total value, but we'll leave it like this for now because it helps to have g, because we can cancel g's out. So that's R. So if we go back in here now, we can say that this is 50 over 3g newtons, and this would therefore be 100 over 3g, okay, newtons. So my next step is to take moments, all right? Now, I showed you in the last two, 1 moment from the pivot and 1 moment where we chose one of those, okay? So you could choose whichever one you want to do this time, all right? Let's just choose this one, okay? Something different. So we're going to take moments from point D here. So moments from D, let me label these so you can see what I'm referring to. So moments from D. Now, what does that mean? If I take moments from D, it means the reaction force at D doesn't count. So RD is equal to 0. Next, I need to establish my clockwise and my anti-clockwise. So if I'm taking moments from here, I have these two forces. This one will be going that way. So therefore, this one will be clockwise, and this one will be going that way, which will be anti-clockwise. Right? So let's start with our clockwise. So therefore, RC, which is 50 over 3g times by the distance to this. Now, I forgot to do one thing. I need to do that again and to go back, which is to fill in the missing lengths. All right? So what do I know? I know that this is 1, this is 0.2, so therefore this is going to be 0.8 meters. I know that this is 1, this is x, this is going to be 1 minus x. All right? So we want to go from there to there, so therefore it's going to be adding these two. All right, so let's just quickly add these two. 0.8 plus 1 minus x. So 0.8 plus 1 is 1.8 minus x, and that's what we have there. So it's going to be 50g times 1.8. In fact, I should put this in a bracket. It's better there. All right? And it's going to be equal to the anti-clockwise, which is 50g times by 1 minus x. There. And I will just work that out. Now, like before, we can cancel out the g's, because we can divide by g's, and then 50 over 3 times by 1.8, 50 over 3 times by x. Work that out for me. And that side too, please. So what's the answer? What's that? 50 over 3 times by that is what? 30 minus 50 over 3. Just leave it like that, yeah? X with an x. Okay, equals to 50 minus 50x. So this is what we have when we expand it out. Now, we've got 50 here over 3, 50 over 3x here. We've got minus 50x over there. Let's bring all the x's onto one side, okay? Let's take the x's onto this side. Or we can just multiply by 3 everything throughout, so we can get rid of the fraction, all right? Whatever way you do it is completely up to you, all right? So what we're doing, we're going to take this over here. Yeah, so let's take this over here and then that over there, okay? So what do we get when we have 50 minus 50 over 3 plus 50? 100 over 3. So 100 over 3x on this side, and on the other side we should have 20. Now all we have to do to find our x would be to multiply by the 3 here and then divide by the 100. Off you go. And the answer is 0.6 meters. And there we have found the answer for x, the distance for x. Now if you read the question again, it says for part B, the support at D is removed and is placed on a point E on the rod, where E to B is 0.4. All right? So part B of this question says that this is removed and is placed somewhere else, and it's given us a distance now for D to B. So what we'll do very quickly is we'll draw, when you do this, draw a new diagram, okay? But to save time, I'm going to use the same diagram and just make adjustments. So I'm going to remove this support here, and this all changes. All the dimensions here changes. In fact, all of this actually changes because the reaction force will be different now, okay? So that will change as well, all right? So this will remain because that center of mass is still the center of mass. So what happens? The support is now placed at point E on the rod. Let's just write E here. And this is going to be RE. Okay? There's a new place where it's gone. And it's also placed a mass right there. And that mass is unknown, so we're going to call it mg. And we are told that this is the distance 0.4 meters. What else does the question say? It says that the magnitude of the reaction of the rod at E is 4 times what this is here. So therefore, it will be 4R. And we need to find the value of this M. So let's get rid of all these calculations because none of them would be relevant anymore for us. And let's look at this diagram. So this is the diagram that we have now, okay, that we have drawn. We've got a missing length here, but we can find that quite easily. If this is 0.4, this is going to be 0.6 because this is 1. So that's 0.6 meters. Right, let's start with a new resolving vertically. So we've got that plus that, which is a total of 5R. This plus that. And that's equal to 50g plus this new mass here, which is mg, or this new weight, mg. So therefore, R will be equal to 50g divided by 5 and mg divided by 5. 50g divided by 5 we can write as 10g. And mg divided by 5, we'll just use 1 over 5 mg. So this will now be considered our new value for R. And therefore this will be 4 times that. But we'll do something really smart. In order to find the M, right, which we'll need to do our moments from, if we take moments from here, it means we don't even have to worry about this 4R and multiplying this by 4. All right, so let's do that. Let's take moments from E. So moments from E, which means what? That 4R would be equal to 0. So the reaction force at E would be 0. So our clockwise and anti-clockwise now we have to determine. Let's start with this one, mg. Is it going clockwise or anti-clockwise around here? It's going clockwise. This is also going clockwise, isn't it? So that's going to be the 2 clockwise equal to the one that's going anti-clockwise. So the 2 clockwise, so mg times the distance, which is 0.4. That's 1. And then r. Now what was r? R was all of that times by the distance there. So let's write all of that. So 10g plus a fifth mg in a bracket times by the distance. What's the distance here? You need to add those two together. So what's the distance? 1.4. The distance is 1.4. So that 1.4, I'm just going to put it here because it makes more sense to have one number in front of the bracket rather than at the end of it, okay? And then that will be equal to the 50g going the other way. So it's going to be 50g times by 0.6. Now all that's left to do is to simplify that, okay? So once again, can you see a g? We can cancel the g's out. Divide by g. And then we have 0.4 m. And then now this 1.4 times by 10, which is 14. And then 1.4 times by 1 over 5. If you could do that for me. As a decimal? 0. So we get 0.28. Oh, forgot the g. Forgot to cancel the g out there. Okay. So 0.28 m. And then that's equal to 50 times 0.6, which is 30. Add the two m's together. So we get 0.68 m. Take the 14 to the other side, we get 16. And therefore m would be equal to 16 divided by 0.68. So what's the answer there, please? And the answer for m is 23.5 kilograms. And that solves part B. In the next lesson, we will be looking at non-uniform rods and tilting. Non-uniform rods is when you have a rod where the weight isn't equally distributed. So therefore, the center of mass wouldn't be right in the middle. So stay tuned and I'll see you in the next one. Bye for now.